Imagine you are a manufacturer based in the US, but you're importing parts. It's expensive. You need massive factories. You need a huge amount of scale to make the money so that you can actually justify your business. And all of a sudden you have a policy that comes through that changes how you bring in parts, and maybe you can't find local cells or you can't find a certain component. And the next thing you know is you're going bankrupt and you're in the red.
The US market's really turning a corner right now, especially on the battery side with the advent of AI and sort of the power consumption we're expecting there. If I just think about the history of our industry and sort of how products have continually evolved through time, just think about 4 to 5 years ago when many of us had these sort of not pre-populated battery systems where it was the immature side of the industry when we had battery modules that were separate. We were racking those physically 200-pound modules into each battery system. Sites would take maybe 10 times as long to build in terms of capacity.
Good morning, everyone. Welcome to the Interchange Recharged podcast. I'm Sylvia Leyva Martinez, Research Director at Wood Mackenzie, and we're coming to you from the Power Up live stage at RE Plus 2025 here in Las Vegas, so really, really exciting. And today I'm thrilled to be discussing one of the main topics that have been around in the conference, which is navigating policy uncertainty. I think uncertainty has been the word of the past few months, and how the different policy changes that are happening in the market are being navigated by developers, manufacturers, off-takers, and all different stakeholders in the industry. So to discuss more about this, I'm really happy to be joined by Neil Bradshaw and Ryan Chen from Hithium.
Hi, Sylvia.
Hello, welcome to the show. So Ryan is Chief of Staff to the Chairman at Hithium Energy Storage, and Neil is Director of Global Applications of Engineering at Hithium 2. Hithium, for those who don't know about the company, was founded in 2019. It's a leading manufacturer of premium stationary energy storage products for all applications, from residential all the way to utility scale. And they have 4 distinct R&D centers and multiple intelligent production facilities. So Hithium's innovations include groundbreaking safety improvements, we're going to talk about that in the show, and other innovations that help increase the life cycle of energy storage projects. So welcome again to the show, and just to get started with the questions. OB3, definitely part of the conversation across the conference over the past couple of days. And it has introduced many changes to the energy sector. So how are you seeing it reshape supply chains, and what is this uncertainty creating for companies that are trying to plan in the long term?
Yeah, I guess I'll start with that one. I'm our strategy and policy lead here at Hithium, based in San Francisco. I have an exclusive focus on the US market and our global initiatives. We've worked with some third-party organizations in certifying or attempting to certify parts of our supply chain before this show. Certainly has been a very layered journey, I would say. The bill of materials we deal with in renewable energy are extremely intricate. Solar modules actually might be some of the easier ones in the industry, but when you get down to a battery cell, integrated utility scale system, there's 1,000 to 2,000 components. Future systems may have more. Many of these are transshipping through different countries, going through distributor warehouses, being chemically processed. So it's very complex and presents a lot of challenges, as we have a local manufacturing facility in Mesquite, Texas, that gives us instant access to US supply chain. But at the same time, we do have our R&D based overseas with some local teams as well operating on that. So we're ready for the policy and excited to share more developments with the crowd here.
And I'd actually add, it's one of those things that doesn't only affect what you might think of as a traditional Chinese company. Imagine you are a manufacturer based in the US, but you're importing parts. It's expensive. You need massive factories. You need a huge amount of scale to make the money so that you can actually justify your business. And all of a sudden you have a policy that comes through that changes how you bring in parts, and maybe you can't find local cells or you can't find a certain component, and the next thing you know is you're going bankrupt and you're in the red. So it has unintended side effects.
Yes, and it seems like you're mixing the best of both worlds, because you have local manufacturing but also pairing it with extensive R&D activities abroad. So it's a good dynamic to have and a way to diversify and try to obtain the most of the innovation that you can get overseas, but also applying all these new technology in the US. So that's definitely exciting. So how do you see, or what does it take for a US-based factory? Like, since you're having the experience locally, but also abroad, how difficult or what needs to happen for US factories, particularly on the battery storage side, to compete with imports from China, from other countries, since the cost structure is very, very different, and also the appetite for different products differs greatly depending on the players locally?
Yeah, I think at Hithium, we've taken on the challenge by building true scale. There's been many overseas companies that have built assembly facilities here. These are smaller scale operations, mostly running a warehouse type operation with some minimal type of assembly. Capital expenditures to build and operate that factory are slightly lower. We took an aggressive move in the sense where we built that factory before we had the offtake purchase agreements lined up to buy the product. That was confidence in our core product ability to sell in the US. I would say some fun sort of features of our factory that really show the scale. One of the things I've only seen in China before has been one of these RC sort of remote control cars that can move a 50,000 pound to 75,000 pound shipping container that's completely autonomous, has no man driver. We have that in Texas right now, and we have multiple of those that are moving the containers between our container integration line and our battery pack line. So just that alone already shows how we're not only just transferring this whole concept of assembly, but we're transferring, I would say, manufacturing scale across oceans here. So that certainly takes not only a lot of knowledge, but I would say a lot of commitment, be it financially and sort of from just an overall mindset as a company.
I'd say as a country, if you want to compete with something as efficient as China, you need to make it easier to open factories, encourage foreign factories to come here and bring the knowledge back.
Yes.
This is the goal, right?
Yeah.
So the government needs to help.
And it's interesting because in spirit, all the new policies are supposed to be helping promote domestic manufacturing, but then what we're actually seeing is reduced investment because of all the uncertainty and all the changes that we're seeing, right?
Fear doesn't help investment.
Totally, totally. So it seems like there's a lot of opportunity, right? But for energy storage in particular, and I'm going to tie it to the comment that you made earlier, Ryan, about how it's easier for module manufacturers. I don't think many solar manufacturers are sharing those thoughts. But it's definitely a bit more complicated for the energy storage side, particularly because of the high concentration of IP, of technology that is currently in China, and well, the situation that we all know of about relationships between the US and China. So what are the biggest weaknesses on the US solar supply chain right now, and how are different companies adapting to that?
Yeah, I might shift to energy storage since that's sort of our core product we're operating here in the US. But in terms of supply chain, I would say the overall policy environment has many inconsistencies. I would say we don't see that as a challenge, more so as just how the world works. We need to navigate through it. Tariffs, they were easier actually when they were high and sort of consistent for every country. Now it's sort of low and high. It's varying across different regions, different countries, and there's various media outlets out there. I'm a subscriber of the New York Times, and I have their tariff tracker table. And one of the reasons I bought that subscription is they update it all the time, and I'm able to track every little country our components are coming out of. It's especially challenging for companies that are actually diversifying their supply chains. So we have materials coming from Latin America, Europe, Middle East, North Africa, in addition to China and greater Asia Pacific. While it remains a challenge, I would say it doesn't deter commitment for domestic manufacturing. I think the appetite from the customer base has been clear. They've been willing to pay for a domestic-made product. Any sort of larger U.S. footprint on a product is preferred for various sort of qualitative reasons as well. So,
and weird things happen. Sometimes you just can't get that product here in the US because businesses have closed down, they've gone away, they've gone overseas, exported talent.
Okay.
With a part that wasn't approved by engineering, or we got engineering to approve something that's very, very different from what we wanted to achieve the same effect, like maybe we can't make a plastic cover for a battery module, we might have to make it out of steel. And that's changing the design. It affects the certifications.
Yes.
And then the customers are confused because they want the same product they've already approved somewhere else, right?
Yeah.
You can't have 100 different products because you have to keep on compromising every time you can't fill in your supply chain.
Yeah, so it takes time for the redesign, first of all, but also a lot of education for the buyer because, as you mentioned, they were expecting a certain product that is already, they already saw it work, it has been proven, so now it's going through all these processes again, even though the end result is relatively similar. Again, like it's just a matter of adapting and educating, so it takes more time and resources.
Definitely.
And is there any risk, for example, like changing the design so suddenly, like in terms of, I don't know, safety, functionality? Ultimately, you're looking to achieve the same functionality as the original product, but then how are the clients reacting to how these new changes to the product are being applied?
They look at it with a magnifying glass. They ask 100 questions for every change. They want justification. And sometimes the justification is just because that's the only thing we can do.
Okay.
And the other thing is we are exposed as a manufacturer to liquidated damages for late delivery.
Okay.
And now you have to go and get your product maybe recertified again and go through all that nonsense. So it's actually very risky for everyone, and all these costs get passed on to the customer.
Yeah. And right now, when we're in an environment where we need all the resources deployed now, time becomes of much more essence. So.
It is.
So you were mentioning earlier about the ability to have like U.S. manufacturing, but also R&D abroad. So how sustainable is this hybrid model where you're merging local and global innovation?
I think it's perfect. I think you can have R&D abroad. You can learn as much as you need to learn. And guess what? While you're interfacing daily with those R&D engineers, you're busy learning and you're actually sharing skills. And we want to localize. We want to localize everything. Manufacturing, we want to localize engineering. But the question is the pace.
Yeah.
We can't do it tomorrow. That's not practical. And maybe it'll take 10 years.
Yeah.
It could be a long road.
Yeah, and I would say the pace of the industry is really set by the aggregate of global sort of R&D policies and incentives set by different countries. In many ways, a lot of the leadership from China in electric vehicles, in battery technology, that's been a heavy push from their domestic market, and we've seen benefits in countries worldwide, meaning our competitors here in the US, in greater Asia Pacific, they've made heavier investments in R&D to sort of release new product that we're happy to see sort of get the industry to a larger scale and at a better cost structure.
Yeah, totally. And what do you see as the main changes that need to happen in the US in order to continue developing the energy storage supply chain? I would start saying not changing the tariffs every week or two.
Yeah.
So a bit of stability would definitely help, but what else is in there?
Maybe a small joke here. I think if the politicians stop playing around with their cryptocurrency and investments and actually ran a country like a company, right, rather than enriching themselves, I think that would be a good start. But that's a bit of a joke.
Yeah, obviously the certainty is the obvious answer. I would say not only tariffs, I think specific to our industry, at least after July 4th, guidance on how to access tax credits for these large-scale battery projects. And solar is on its sunset, but there's also some guidance that needs to be there as well. They're subject to some restrictions starting on January 1st. But outside of all that, I'd really like to highlight, I would say the U.S. market's really turning a corner right now, especially on the battery side with the advent of AI and sort of the power consumption we're expecting there.
Yeah.
At this conference, we've released a AI-specific product that really helps deal with the demanding load profiles that all of these AI applications are using currently. So if you think about when you're using a ChatGPT or a Grok AI, and you're getting reminded of that sort of Apple Mac sort of beach ball where it's still loading on you. I think we're all waiting for data centers to get faster and grow in capacity. There's a huge sort of mismatch in sort of power demand and what our grid can currently provide. So we're hoping more policy certainty. We certainly need it because the appetite for our product and the overall industry growth is really at its peak, despite all the challenges we have in the background.
Yeah. How are you thinking about the development of the entire battery supply chain? Like, I think there's a lot of opportunity there as well. What we have seen in solar, which is the area I typically cover the most, is like it has been concentrated on the final product, only the module. But when we take a look further upstream, there's still a lot of components missing. We have no wafers, we have no cells, no polysilicon. So how do you see that evolving on the energy storage side?
Yeah, I think this is maybe the first year I've had decent conversations with mineral mining companies from the Asia Pacific region coming to the US, not only exploring within the US, but greater Americas. But when they get here and they meet with us, they tell us how they've recently taken trips in other continents like Europe and Africa. I would say the demand is not only from the US, other markets, for example, the European market is also driving that. At least in the US, the EV market's sort of on a roller coaster. At some point, we'll follow a more consistent trend, but I think demand from the EV side, demand from energy storage for critical minerals will grow. But I think in certain ways, it's a good thing. I think we are diversifying globally. We sort of have more sort of localization that encourages U.S. customers to make greater investments in the industry. So despite the fact that our parent company might not be based here, we're sort of following and towing that line of localization and supporting the customer base we have here in the U.S.
And we invest heavily in like local suppliers. We give them lots of guidance, and we're really working hard to get it maybe 100%.
Okay.
We'll see. It'll be coming.
Awesome. Looking forward to it. So in terms of the investments, one of the elements that several manufacturers have talked about and that have dedicated a lot of resources to is retaining talent. Particularly now we have seen this wave of bankruptcies, market consolidation. So how is this like reshaping the competitive landscape, and particularly how does it affect the retention of top talent?
Well, I'd say that's quite a violent market at the moment. With some things on the plus side are all these bankruptcies release top talent that you can then scoop up and you can bring in, and you can learn things you would have learned otherwise. But on the other hand, you have a few major players, and they're busy basically trying to build the strongest companies that they can do, maybe driving the talent prices up quite high through the roof in some cases.
Yeah.
And there's a bit of infighting that's happening. But I think the good news is eventually we'll have a consolidation. We'll sweep the board. Companies that were weaker, unfortunately, will end up being moved out because it would have probably happened in the end. So from that sense, I'd say the government's done I suppose the industry a favor of pushing them down. But the good thing is it releases amazing talent, because the people at those companies who had to innovate and they had to struggle and they do things that they didn't have the resources that they needed to do can now be released to the bigger companies, which will be a good thing.
Yep.
Yeah, I would say as shown here, RE Plus, the attending crowd is always impressive, not only in terms of, I guess, size. We're now taking over more and more expo halls each year, but just in terms of the breadth of the talent and sort of a new younger generation that always joins our industry. I think the new crowd graduating from college, it's not only about software and sort of Silicon Valley companies where I'm based out of, but clean tech emerges as a sort of good brand as well. If I just think about the history of our industry and sort of how products have continually evolved through time, I just think about 4 to 5 years ago when many of us had these sort of not pre-populated battery systems where it was the immature side of the industry when we had battery modules that were separate. We were racking those physically 200-pound modules into each battery system. Sites would take maybe 10 times as long to build in terms of capacity. companies have grown and evolved with product. Companies consolidate. Companies merge. They may go bankrupt. They may rebrand. But that's a continual trend, and I think we're happy to be here at the show to see a lot of familiar faces from just a few years ago, and everyone's always switching companies. But at the same time, I think you'll find many sort of bedrocks of the industry where those companies are here to stay, and many of those executive leaders are sort of leading the push forward, especially most recently in the whole lobbying effort behind OB3 and ways to, in my opinion, made the policy somewhat workable compared to the first draft that was released in May.
So we cannot have a discussion about energy storage without mentioning safety and fire hazard. So it seems like large-scale fire testing and other compliance requirements can cost millions and are increasing the time to market of products, right? And right now, time is of the essence, so it's becoming more and more challenging considering the policy landscape. So do you think that policymakers are fully understanding the costs of all these compliance requirements, and what would a better or more pragmatic system look like?
I don't think they really understand the costs. So it was $3 million to $4.2 million when I researched online for some of these large-scale fire tests. They're pretty expensive, and you run the risk of the rules changing maybe halfway through the test or just before the test or a week after the test, and then it might render your whole test invalid, right? Luckily, they have voted in the 9540A, the most recent draft had been voted on maybe 2 or 3 days ago, so that's good news. And that's what we ran our test to, which is great. We did it with all the doors open, which probably wasn't required. That was the worst case scenario, but we were pushed to do the worst case test, which may have resulted in us failing the test, which may have caused us to waste $3 million, say. But luckily that didn't happen, so it wasn't a waste. The customers were all covered. But when you think about it, all these standards that we have, the best thing about standards is there's so many to choose from. There's hundreds of standards, different agencies. They all compete, and very often when you're building a project or a factory or something like that, you're wrestling with having to do things that are inefficient, and you don't actually know which standard to apply in which case easily, and very often it's like a bit of trickery. The experts out there will pull out a standard you didn't know about and say, oh, in this case I want you to comply with that standard. You're like, oh, I didn't design the product or the factory for that case. If we could simplify the standards landscape and make it more friendly for businesses to invest so that they don't have to worry about losing money on projects or on their factories, that will help the country a lot.
I love that.
And I'll give you here's a really nasty example. A few years ago, we were manufacturing inverters from an American company that's no longer with us, unfortunately. And we changed the color of the paint for a client request. The standards agent, the paint on the outside, it went from white to green, right? Just tint. And the standards agency said, not named, they said, oh, we're sorry about that. Now we need 3 samples, 1 to explode, 1 to disassemble, and 1 to do something else with it. And you've got to put a guy in a hotel for 3 weeks. So that this really happens, and then you can be late on your order. It can cause a lot of trouble. Whether the inverter is going to explode or not, and when they blow them up, they literally put a big copper bus bar on an IGBT on the inside of the inverter to blow it up. That's got nothing to do with the color of the paint. So, we have those things to deal with sometimes.
Well, it seems like it can be like a relatively easy thing to do, but it's going to take a lot of time and definitely a lot of conversations with policymakers. So, Neil, Ryan, this has been amazing. Thank you so much for sharing your insights with us. Thank you to the audience for joining us live here today. And thank you, everyone, for joining us here at the Power Up Live stage. See you next time.
Thank you very much.
Thanks for having us.